Now, what are the protocols of IPSec, guys? Okay, IPSec protocols. So there is actually two protocols, guys. One is ESP. Okay, what is ESP? Encapsulation security payload. Fine. Encapsulation security payload. Okay, PAYLOAD. So what it does, it's actually what ESP is doing. Okay, so let me explain something that it is using port number, IP port number. Actually, it is using IP. IP means Internet Protocol. IP port number 50. Okay, it is using IP port number 50. And ESP is actually providing all CIA method. Like ESP is providing the confidentiality, integrity, and availability, all three. Okay. So whatever the packet would be, whatever my data is going, this is my data. Okay. It will encrypt this data, and also it will provide the integrity, MD5 on SHA. Okay. And also availability. So it will provide the all CIA method. Okay. And also it is using anti-replay mechanism. It is using, I will explain what is this. Anti-replay mechanism. I will explain it. What is anti-replay mechanism? Fine. And then there is a other one, AH. What is AH? Authentication header. And then there is a other one, AH. What is AH? Authentication header. Authentication header. Okay, it's a name. Okay, just like ESP. So authentication header, it's actually using the IP port 51. Okay, it's a IP port number, not TCP, not UDP, nothing. It's IP port number. Okay, it's on protocol. It is IP port number, and it is also using anti-replay mechanism. Okay, but the main thing is that it's only providing data integrity and authenticity. It's only providing data integrity and authenticity. Means what, guys? It is not providing the data encryption. It's only providing the data integrity and authenticity, but it is not encrypting my data. Okay, it is not encrypting my data. It is also using anti-replay mechanism. It is also using anti-replay mechanism. What is it? Just now I'm explaining. It is also using anti-replay mechanism. Okay. So guys, if I want to explain something, guys, like I have one data, my data. Suppose I just want to explain. Okay. Whatever land. So this is my data. If someone will even read it, I don't mind. I don't mind if someone read my data. Got it? But there should not be any change in my data. That my data should not be tampered. In that condition, we can use H. Right? Like anyway, I want all CIA method, confidentiality, integrity, and availability. But if I don't mind, if anyone can read my data, it's fine. If I'm giving an example, right? I'm giving the some kind of a a requirement that if someone read my data, I don't care. So that's upon you, because ESP is only ESP is providing all CIA method. It is encrypt the data. So this is the main difference between ESP and H. So now I'm going to explain what is anti-replay mechanism. Anti-replay mechanism is like that, just like same R1 over the ISP. Okay, R2. So guys, we know how my packet is going, right? I have explained it, right? TCP, what, like this is my packet. Okay, all my data. This is my data. So guys, we know that in the TCP, what is transport layer? Na? Layer 4 is what? Transport layer. So what transport? If we have a data, transport layer is actually what it does. It segregate my packet, right? We know that it segregate the packet in the transport layer, OSI defense model, and it will give the sequence number of the data, right? It is segregate the packet. It is cut the packet and provide the sequence number. Okay. And then it will start forwarding the packet, like it will forward the first, like R1 to R2. It will forward first 4 packet. Then it will ask for, okay, send me the packet now from packet number 5. Remember? So this is where the TCP is forwarding the packet. So guys, what is anti-replay mechanism? Anti-replay mechanism is actually like we know that it is first forwarding first 4 packet. Okay, first 4 packet. So then it will this router 2 will forward a message. Okay, I got the message. It will now send me the packet from packet number 5. So then it will send packet like anywhere 5 to 6, 5 to 7. It will whatever it can send. But the packet is going in the sequence. First it will go 1, 2, 3, 4. Then it is going 5, 6, 7. So once 5, 6, 7, once it will like 7 will reach, then it will ask for packet from packet number 8, right? Right? It will ask from packet number 8. So then it will forward the packet 8, 9, 10, suppose. Okay. So now if there is any hacker, this is a hacker, and whatever the packet is going, if any hacker hack it, so hacker will see that, okay, he will hack any packet. So he will think that, okay, packet number 1, 2, 3, 4 came. Now packet it will forward the packet from packet number definitely from 5, 6, 7. So with this sequence number, he will guess it. The next packet will come from the 5 number, 6 number, 7 number. Okay, hacker can easily guess it. What is the next coming packet, right? So there is a things anti-replay mechanism. It will actually does that. It is not going to forward the packet with the sequence number. It will forward the packet with any number. Like it will forward the packet first 9, then 3, then 2, then 6, then 10. Okay, it will forward the packet with the help of anti-replay with any sequence number, right? So it will not going to forward the packet with the correct sequence wise. So that is actually anti-replay mechanism. So if any hacker will hack that packet, he is never going to guess it what the next packet is coming. Got it? What is the next sequence number of packets coming? He will never guess it. So that is anti-replay mechanism is actually helping. Okay, anti-replay mechanism is actually helping that it will provide a kind of a security that hacker will never going to be guess which packet is coming next, which sequence number packet coming next. Now IPSec mode. I have explained multiple things in IPSec. There is IPSec mode. Okay, in IPSec mode there is a 2 mode. One is by default mode. This is tunnel mode. This is actually a default mode. Okay, default mode. And other one is transport mode. One is tunnel mode, one is transport mode. Okay, so this is 2 mode, guys. Okay, now let me explain the tunnel mode. What is tunnel mode? And very, 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 very important, guys. Tunnel mode. Tunnel mode is what, guys? Like this is my PC. You see, this is a router or firewall, whatever it is. ISP or router. This is a other side PC. Okay, PC2, PC1. So VPN is there in between these two. But tunnel mode is what? Tunnel mode is actually a gateway to gateway VPN. Tunnel mode is actually a gateway to gateway VPN. Okay, why it is? So this is actually a gateway to gateway VPN. Why? And I will explain why. So it is what? It is gateway to gateway VPN. Okay, gateway to gateway VPN. Why? I will explain. Why? What it does, it will encrypt the entire packet and add the new header. Okay, it will encrypt the all packet. It will encrypt the all packet and add the new header. Okay, add the new header. This is the most important new header. What is this? I'm going to explain. Okay. So what happened, guys? This is my packet. This is my original packet. Okay, payload or data, whatever it is, payload or data. And this is what, guys? Like this PC has a source 10.1.1.1 and this PC has a source 10.2.2.2. Okay, so whenever this PC will try to forward packet for 10.2.2, what would be the source, guys? Source is destination would be 10.2.2. So this is the actual source and destination, right, guys? And this is my payload. Okay, What tunnel mode does, it will encrypt my all payload and also the header as well. Full packet. It will encrypt full packet. And then it will add one new header. This is new header. I'm typing new header. What is a new header? In the new header, it will give the source IP of the directly connected firewall or router public IP. Like suppose this is IP is 1.1.1 and this is the IP is 2.2.2. My peer router public IP. So it will put the source IP is 1.1.1.1 and destination is my peer public IP 2.2.2.2. So this is not encrypted, okay, because it has added a new header. But all my original source IP and destination IP and my data payload is all encrypted. Understood? So this is actually done by the tunnel mode. So tunnel mode actually encrypt your payload and also the source IP and destination IP, original source IP and destination, and add a new header. Okay. So what happened? It has added a new header. What is a new header? This is a new header, right? The public IP of R1 and public IP of the peer. So that's why this VPN is gateway to gateway. Why? Because if traffic is going from, it will look for the, okay, this is gateway to gateway. Why? Because if traffic is going from, it will look for the, okay, this is a source 11111, and where it will go? It will go for the destination this. So my tunnel is actually built from peer gateway to gateway, peer to peer. Then this router, because the original source IP and destination IP is encrypted, no one knows what is this actually, right? No one knows the original source IP and destination IP. That's why, because only they knows the whatever the new header added, the source IP is public source IP of R1 router and destination IP of R2. So that's why the VPN is called gateway to gateway, because only this source IP and destination IP only aware of this router by both router. Okay. When this packet reach to the R2, then R2 will what it will do? R2 will what? It will decrypt this packet. Then R2 will decrypt this packet. And then once it will decrypt it, then it will see that, okay, what is the original source? It will see the, okay, original source is 10.1.1.1.1. What is the original destination? It is 10.2.2.2.2. Then it will check that, okay, I know the destination. Then it will forward the packet to 10.2.2.2 PC. Understood? Then again, when the reply will come from there, then packet will come here. They are using tunnel mode. Tunnel mode again, it will encrypt the payload and whatever the original source and destination, it will encrypt it and it will put the new header. Source is become this IP and destination is become the peer public IP. That's how the return packet come. What is transport mode, guys? Transport mode is what? Okay, just first I'm explaining here. The transport mode is, this is my data or this is my original packet. Okay, the diagram is same diagram, 10.1.1, router 1, ISP, router 2, PC 10.2.2.2. So this is actually, this source is this PC1 to PC2. Okay, this is source, this is destination. Source is 10.1.1.1. Destination is same 10.2.2.2. Fine. And there is data. So transport mode is only encrypt my data. That's it. Transport mode, please note it down, only encrypt my data. Only encrypt the data. That's it. And it is not adding any new header. No. So that's why it is end-to-end encryption. That's why it's called end-to-end VPN. Why? Because the source IP and end-to-end source IP and destination IP is already visible. So packet will go from this PC to the till end. The VPN would be from end to end. You can mention that transport mode is a end-to-end VPN, end-to-end or either host-to-host VPN, and it will only encrypt the data. This 2 point you can write. It is host-to-host VPN or end-to-end, whatever VPN. Second, it is only encrypted the data. It is only encrypted the data. Fine. The original IP header will remain same. So this is what the transport mode. So we know the difference between transport mode and tunnel mode, right, guys? Transport mode, it will tunnel mode encrypt data and source also, source destination IP also, and add a new header. That's why it is gateway to gateway. Transport mode, it will only encrypt the data. It will not encrypt the original source IP and destination IP. That's why it is host to host.